So here's a reaction video, and also I hope this horse guy runs across the video so he can learn from what I'm going to educate him on. So let's first hear what he states. That interesting. Yeah, he says he's got nice resources. One guy's he's going to say the soil guy. He does his excavating. He's going to tell him there's a lot of stuff they grab from the mills there, and they recycled it as the base. He never sees the site. He just tells them that's what it is, 19, whatever it may be. Let's see.
Oils, how to dig it, just everything there is, machinery. So I reached out to him, and I said, hey, Mike, how do I go about getting a soil study? So he said, tell me.
First off, him asking for a soil study was premium, all right? That's awesome. Hoss is saying, I'd like to go the extra step. Hoss, your answer is a geotechnical guy does your soil studies, all right? But you don't want to so much that. You want probably more, since you haven't seen it yet, and I haven't seen it yet. I was thinking more of wait, let me see. I can't wait to see this pad, because he says, what is causing this? I think he says it's heaving, meaning swelling up, not up.
Why? What do you need a soil study for? So I filled him in on this industrial plant we're working at, and he said, well, when was it built? And I said, well, back in like the 60s, 50s or 60s. And he said, well, I guarantee what you're going to find, you're going to tear up some concrete, and you're going to find compacted, rock-hard dust. All
right, you're guaranteeing rock-hard dust.
Granular dust. And he told me that is, and I apologize if I get some of the terminology wrong, like a slag dust. It came from the old mills, and it's a byproduct, and it was cheap, and they used it underneath slabs because it was real nice to work with, and it compacted. The only problem is they found out that once it gets moisture, it expands. So I'm going to go ahead and tear up.
Okay, so slag, right? But the title is, there's the pad there in the background. And we see dirt right now. Let's assume that the slag has been removed down to the dirt. Which, if we look at the soil, the top of the slab, and then where the soil is, well, that's not much slag. So if it was slag, and therefore not enough force behind it to force a pad up, heave a pad, all right? Because if you only got this thin layer of, say, slag, and then you have your soil, when this goes to heave, pressure up, it's also going to be pressure down, compacting the soil here. Now, compacting that soil there and then shrinking after moisture would then leave a void between your concrete and your soil. The void is here. You then load it with vehicles, what do you call those things? Forklifts, etc. Because we see they got forklifts. And then you can get cracking. Okay. So where I'm looking at here, oh, I see where the rain comes through this roof. That's how it penetrates through the concrete and swells up this slag. Oh, ground soil comes up. It's wet, and it comes up. Well, his machine looks like it's pretty dry there. Oh, wow. Looks like you can get a triaxle inside this structure. No problem at all. Yeah, okay. So now we're starting to get a history of loading. Okay, let's go from there. Okay, so now I stopped the video about another minute into here when he does a hole puncture. But first off, he said heave. And so I'm starting to trying to find heave, right? And I'm not there. I see where this looks like it might have been two different concretes. I see the yellow line doesn't appear to be cracked, fractured. I do see some loading, all right? Some uniform distributed load ×2. I don't know exactly what's in these items. But this is the garage door open. This is where your heavy equipment comes. And what do? They surge. They put on brakes. And when they put on brakes, you create an extra force, surging. They come in here, they grab, they back up, surge, stop. And now we have this tributary area that appears to be fractured. Tributary area is the zone in here. So they come in, they slamming on brakes on each side, and let's go from there.
Same thing the whole way down there. Just a huge hump.
All right, so let's assume that he sees the hump. I don't see those humps. I see fractures, compressive fractures, not open like this. A hump, right? Would be open like this. I see something like that. Those are compressive breaks, more like that. He's saying this hump is what he's saying he sees. Starting where? Because I don't see any fractures here. All right, no fractures here. I see the tributary fractures in the middle, but to create that hump, you're gonna start wanting to fracture the outer wall here. I don't see that yet, but I won't. I don't think I will either. I only made it so far.
If you remember last year.
Okay, so look at this equipment there, and you can see the displaced concrete. That it's high and low here.
We did a strip along there, and we had.
And this is just concrete being driven on. Trying to bypass each other, and you're getting all these fracture and spalling off as it grinds. So he said he did a repair here, it sounds like.
Talked about doing something more then, but decided to hold off, and maybe we'll address it all right now.
All right, so there's the one I'm talking about right here. So he's talking about hump, but all I see is tributary, the center, all these fractures, right? Let's map them. All I see is a lot of load fractures where the heavy equipment kept driving across it, slamming on brakes, and just fracturing the hell out of this inferior concrete for what it's supposed to, for its loading capacity. And I don't mean concrete's inferior. I mean that it's not what's needed. It's the wrong. So I'll
move all this back. Right here is where we're getting started.
Okay. All right. Let's watch him go into this, into it and see how easy it penetrates. It might be a machine, but we're going to watch him penetrate. Okay, he flips it up. As soon as he flips it up, I see that, okay, it's not very thick. Also, it already has a break across it. So you just pause and get him when he comes up to it.
Concrete, we dug out about 4 inches.
All right, so there's about 4 inches of concrete. So now, he talked about heave, all right? Well, it looks like we got a vapor barrier, first off. Let's see the vapor barrier. We don't have that ash. We have crush run to a degree, pretty clean looking. Looking for water content. I don't see the moisture down here as he's moving it with his gloves. Looks like they've got 4 inches of concrete on which they cannot take on top of some stone, and then remember we saw the dirt. So it looks like the compaction might be an issue here in that the concrete can't take the loading. It's 4 inches of concrete. Can't take the serious loading that they're applying to it.
The limestone, and look at all this sandy. It even smells like slag.
So as we observe him digging, what do you observe is pretty tight, and he's using a 6-foot wrecking bar, if you will.
Sample. This is limestone and subbase. Now I got rid of all the limestone. Now I'll get a sample just down here. This stuff is really hard, just like Mike said it would be.
He said he got rid of the limestone.
So I'll dig a little bit more, and I'll put it in its own separate bucket.
Okay, good. Pretty hard, right? Compacted. Dry is what I want you to notice. It's dry.
He said we'll probably see about 6 to 8 inches of it.
Dry.
The concrete was very thin. That explains why the fork trucks were breaking it up.
That's right. Simple as that.
It doesn't explain why the floor is heaving like it is.
I don't believe it's heaving.
So with that sub-base material, I'm going to run it over and have it looked at.
Oh, well, I paused it, guys. He said he might send it out to a lab. That's
and
good.
Get it, and then we can determine the best way to go. So here we are, back down at this plant, getting ready to do demo. I took my samples home, and I called my friend Mike, who I was going to report to. Unfortunately, he was out of town, but I described it to him, and he said, without a doubt, mill slag. So as I was taking the sample, a couple of guys from the plant were standing there in the background, and they said, "Oh, look what you found under there. That's mill slag." I remember that smell, and it gives off like a gassy smell as you start messing with it. So there's two. So one more step. I took the buckets to another excavation company that I work with sometimes, and I didn't even give him the background on it. I said, "Hey, what do you think this is?" And he looked in the bucket, and he said, "That's mill slag from the 60s. So all the arrows...
Stop. Change directions. That's your heavy low point. Coming in to grab it, they're going to go nice and easy. Pick it up. Start coming back, pick up momentum, and then that's the charge where they stop. All right, so for fairness, this is what he's saying. It's a hump in the middle there. Okay, so now I would see an elevation change here. I see this and an elevation change here. I would wonder if the person he is renting this property, but I think responsible for repair of the net. You know, the contract says, you do the repairs, I guess. However they word it. But he says this is where he sees the hump. All right, well, he cut out a section here. He can clearly look for voids there. And if there's no voids, you can't raise it, right? You can't raise it. So I don't know the temperature of this room, but I'm also trying to think of the atmosphere in here. I know they got doors or opening. I don't know what this stuff is. But he says there's a hump. I see they're loading on this side, all left, loading on this side, all right. Is he looking at hump there, or is he looking at settlement on this side and giving a false illusion of the hump here in the middle? Because we have a hump, if you will, and also fractures. So we got combination. But we got our permanent loading, our creep, right? Permanent loading to the left and right of this. This is where we'd want to look then at the walls to see if we see any settlement over there. Okay. So I'm not sure what I'm looking at to the right here, but it almost looks like a keyway system. A keyway system that they keyed the pad in, existing pad from the right to the left. And over here, no keyway, just butted up to it. This is significantly clean, and, well, he cut it. But it's also sharp. But it looks like it's got a lot of fractures ready to start happening. He did some digging in here, so I can't really count this as I can't really say, oh, I see a void. I'll be seeing ghosts, as I call it, making it up. Over to the left here, it looks again like the keyway system. I wish you would zoom in on that, but that's what it looks like. So that means this pad was at it. Different pad system. It doesn't look the same as this, but he cut this. But he cut through, and I don't see the overcut there, so that's interesting. I don't see that. I think this pad goes here. If you look here, let's see if we can get to see that. Can't quite. Might be under that he cut the top and chiseled it. He could have just cut this top a little bit and then chiseled it and created that effect. I say that because I look over here and I see that it looks like solid concrete. Looking around these poles, it looks like it's stable. I don't see any fractures off of them, so the temperature-wise, let's go on. I think you should hear this part.
I'll cut 4 feet back and remove that. There's a big crack down the middle of this pad.
There's the crack. Okay, so this will be a heave crack. is what Hoss needs to look at, is here, right there. So it would be, if this is heaving, this would be open here like that. Okay, let's exaggerate. Compressive underneath, where it's compressing. You see some spalling off here. I don't see spalling. I see what appears to be multiple fractures. You know, I don't know what that is. But there's the fracture there. Seems like it's bound. This concrete is bound also. So when you go to press it, deflection happens, all right? So when you go to load this deck, all right, it's just like a wooden floor. You go to load it, it has to be able to flex, move. Concrete being rigid, it can't flex and move like, you know, let's call it a bridge. It's pinned. It's boxed in. Let's lock it in. No expansion joints. Let's lock it in. Now let's load this. It can't push out because it's backed by all of this concrete over here, right? I just made this larger for demonstration purposes. So it can't do anything. It can't, the load is enough where the concrete can't stay rigid like a bridge, like a truss for the loading. Tractor trailers, triaxles, that's a 6-wheeler. And so now we have to have, it displaces. So his camera, he's got a probably helmet cam, but it looks like that a little bit, doesn't it? But the camera could be.
Big hump in here. That's all that expandable soil. That's mill slag.
Yeah. Expansion joints, tons of them. Okay, so he's removing out a lot more soil. And we're only got the 6 inches. Now, let's talk about how this breaks. And I think I like that. I mean, his video, looks how long it is. Yeah, I think I got to cut it short. But I want to talk to you about loading again. And I want you to see this tire and how it's on the edge of this concrete. Well, the concrete at this point is in cantilever. All right, I want you to think of it like that. It's the soil, right? Let me just do this for soil. His tire is here. What's transferring the load of let's change colors a bit. What's transferring the load from this side, side 1, okay, to side 2? Is it rebar in there? Anything? Probably not. All right, maybe they dowel or not. Doesn't matter. Doweling is usually done inferiorly without it's not done enough to take the load. All right, so here's your load, and this is what happens. Because this loaded his tire. Remember, he came to a stop. That creates a shock load, engine, all of the weight. Well, you know, if you go through motor vehicle testing, slam on brakes, they can tell you all the time your load. You know, it's always the front tires, like this situation with the engine up front, that will create more load there. So you got to slowly work your way onto it. Forklift operators are not going to be doing that. So each time you cross a line, you get into this plane here where it's most weak. That's in the cantilever of the pad. So this pad would have to be really supported structurally where no deflection can take place. So in real life, under here, the soil would have to be super stable at that area. Otherwise, you're going to get a crack right about there, visually from the top. As you come further in, it starts distributing it between this side and this side. A lot better, if you will. I'm not saying sufficient, but better. Okay, so to surmise, he believes if he goes down any deeper, he's already hit a hard rock that he thinks he would hit water table. Well, just drive a ride through it, okay? Grab a ride, drive it through. And there is a construction joint. It looks like he lost it right there. See the top joint? And his pad is significant. So it is that, as I showed you, down this plane here. All right, some of it appears to be added. They did use a vapor barrier, all right, so the moisture not to come up. Where he's cut out here rather, he didn't undercut. I see the materials in line. I'm gonna move that kind of perfectly with the soil there, so it's loading. directly onto the soil at some locations, unless he got pushed up when he was using his machine, pushed up over there, displaced over there. That's also where they load the side of the structure, where we don't have the fractures. We're in our tributary area of the traffic. We're in our roadway, if you will. All right, let me give this again. I hope Hoss doesn't take this as insult. You know, some people think like you're stepping on the toes. Hoss, you had heavy equipment on here. You had your excavator loaded with excavator, and also you had your track machine, along with whatever's in the bucket. When it pressures this soil, all right. So here's the track machine. When it pressures this soil, along with the bucket full of materials, 500 pounds, 700 pounds of material, it increases the pressure on the track, of course. So you've equally distributed the load across the tracks, pressing on the soil. When you did that, you didn't displace water to the top of the surface. So you look for H2O, right? You didn't displace water or any liquid to the top of the surface during your driving. So yes, you may smell it. It may smell damp, or you may have the feeling like it's damp, etc. But you did not bring it to the top. So you're golden. You're still good. You didn't, with that load, you didn't do it. Now, if you can get a forklift down there and see what happens, you've got a piece of test equipment there that would focus the load a lot more. You can also, Hoss, in the future, grab some 1 foot blocks, your concrete blocks. All right, let me clean this up for you. So I want you to grab some 1 foot square blocks, or even 6 inches. All right, you put it like that. And I want you to run your track machine on it. So now it's no longer evenly distributed. Your tracks will be on top of here. Okay? You're going to go above there. Now your load's here. And overnight, since you've had a chance, Hoss, to leave this overnight before you come back, overnight I want you to observe how much, if any at all, these impress into the soil. So you're load testing. The smaller you make these, the more concentrated the load, the more you'll be able to observe it. Don't dig around it or anything else. You know, just flatten the soil out. Don't do any extra. You want a true visual. Remember, your concrete, though, no matter, will be distributed load up here, but will it fracture is the question. Your rebar is not going to help you too much with that. You want to get the soil tight. You want to get the soil tight. You want to get the soil tight so it doesn't do this. Okay, so he's got a plate tamper going. All right, this is great. Roller would have been faster, just so you know, run a roller, rock with it, roll with that roller. The plate tamper is why I'm here for you guys. When it starts dribbling like a basketball, bouncing back, that's about when you got that's as tight as it's going to go. Imagine putting it on that concrete right now. It would dribble. It wouldn't be able to do anything. Well, that's what you want with your soil, with your compaction here. You want it to start dribbling. So you're going to go over and over and over and over again until it starts dribbling. If it's not dribbling like a basketball, you're not tight enough, or you need a heavier compactor based on the thickness of your stone. Okay, I had to back the video up because just in the next second, you know, a lot of times I got to listen to it and then I go, oh, okay, I got to back it up and record this part. Here's confirmation of the tractor trailers right here.
This is a final check. We're going for about 8 inches thick. They back tractor trailers in here. We're not that thick over here, but that's what we're doing.
Okay, so not that thick over there. So you can see now Hoss, you might hate me on this one, so take the good with the bad. All right, remember the track of the path of the tractor trailer, where the tires are going to be. Right here is where it's the weakest. Remember the cantilever effect. And then when you enter on that side of the pad, the same thing. So this side needs to be so taut. I mean, you could do little fun things like dig down 12 inches and let 12 inches act like a mini pier there, where it loads on a pier on that side. This side, you're done. It's already existing. So it's probably going to fracture there. the tributary area. So here, let's do the truck path here like this. Everything in the middle is almost fair game. All right, so there's your truck path. That's your most critical point. Of course, the truck might move left or right where my man is here. So, you know, all while you're here, all this is going to be critical where you want it to dribble. What we got here? Gasoline, maybe. Looking at the pad here. Seam. Okay. So if you want to know what it's going to do, you would put an expansion joint, which would be in the form of just a saw cut right here. And if the trucks drive on it and it dips and it drives down, well, there you go. There you go. It's loading. But this should not help it. A saw cut won't. You'll give it its own little path. All right, and you can keep working on the path as opposed to working on the entire pad. Oh, I'm sorry. I should make it clear. And for clarity, they can lay down, Hoss. They can lay down They can lay down markers saying this is your tire tracks. All right, this is where your tractor can go and be unloaded from. This is the design for the tractor. All right, this is the bridge. This over here is the walkway for whatever. But again, that looks like just a sky reach, but a man lift. But the forklifts are also troublesome. Okay, so now he's going to go over the inches. Now, the depth, all right?
Checking my grade.
I want to show you something when he gets to it. All right, right here to your right. Concrete would definitely have to get under there, or you've got a point where it's just going to fracture. Okay, let's go. Let's keep it going.
9, 8, and 8. And that
right there. That's where I want to stop it. Okay, so now we've got right there. So in essence, we have this profile at, well, I don't know, we've got 3 to 4 inches right here. So when they drive on it, this will do what? Fracture like that. He has to pull that concrete out, underpin it with some concrete, right? Make it so it's solid. Underpin it. All this here. Take all this out. Underpin it with concrete. And that would make it a solid, all this here too, a solid position. It's inside building. Do I care about the triangles there? You know, I like to see expansion around the entire thing. Around the entire thing, isolate the entire pad. His work. All right, so he's putting down 8 inches. Again, dribbling is what counts. I'm not sure. Now, if that Tamper can do that, I would argue 8 inches is excessive for it. The tractor trailer loading is what's done in a lot of time on roadways. You'll see tractor trailers lined up, and you'll see them just driving down the dirt there. That's the way some DOTs, Department of Transportation, test this. He has a six-wheeler. He can load a six-wheeler up, load it up, and then drive it through here and look for impressions. Yeah, drive through your own work, all right, through your own stone, and see what it does. All right, see what it does, and you know, and test your soil, your compaction. Okay, so now he's bringing in a concrete truck. The tires are, yeah, it doesn't have his other wheel down. All right, so that would be depending on how much load he's in there. Protecting your job site, you would ask him to put down the other wheel for you. Just distribute the load more. All right, yeah, it doesn't turn as easy, but just protect your soil. Now he's on the on that zone I told you about. He's right out here. So his tire loading is here. Wide tires though, a lot of just distribution of the load. So his fracture might look like this, as here's his tire. So this is how he's stressing. This is how he's stressing that area there with those tires here. Over here is a little more developed, a little more room on there, but on the edge there, he's at the edge. It's so-so. Okay. Vibration, rotating of the truck depends on the tire, what the tires are going there. Let's look at the reinforcement. Yes, this is a critique video. So a rebar drifts. All right, so quality is not there. All right, sorry, Haas, it's just not there. What you do, Haas, to do this, and you can take it as criticism, I hope, constructive. When you lay out your rebar, all right, lay them all together. And if you're going to do it 12 inches, get your chalk line and mark 12 inches as they're all lying together. Okay? Now, when you lay it out, your rebar will all cross there, and you know they're all going to be 12 inches. Paint it. Or whatever spacing that you've used. I think you used 2-foot spacing. That's significantly huge. I don't know what size rebar. You did dowel into some defective concrete in many places. I'm not saying right there because I don't want you to think I'm trying to slandering you. I'm just saying that some of them are doweled in some weak locations where it's useless. You said 3 inches is where you're going to dowel into the. You said you're going to use chairs. So your chairs here, 3 inches up, 8 inches. So we have 5 inches of that location. Not quite hating on it, but again, the loads matter. Where the tractor trailers are going to come. So tractor trailers and their tire loading. This is the weak joint here. Transitioning over to there would be weak onto the next one going up. This is where you would underpin that with concrete, like something like the column idea. Anything more, 12 inches of concrete there, underpinning it with concrete. So you talk about your vapor barrier. You got your vapor barrier down. The temperature in there, I don't know how it's controlled, but you worry about curling, moisture, things like that. So right there you have your vapor barrier not overlapping. So there is no vapor barrier there. So moisture can come up and get between your pad or some maybe escape between the cracks. But it can come up and get between your pad and back onto your vapor barrier. And you don't have to worry about freeze thaw. Inside a building, I think it's pretty controlled. So I'm not crying. I'm just saying, fit and finish. All right, your overlaps, I can't quite tell your overlaps here. Some of it's doweled. And let's go. So again, no expansion joints, all right? So you're making new concrete, but into old concrete. If we think of this as brickwork, you don't do, I don't know what PSI you have there. You don't know what PSI is existing. So they might expand differently when temperature variances hit them. So it matters. And no expansion joint. Controlled environment, gotcha. But again, remember you're locking it in. There's no room for expansion. There's no room for any heave. Any heave as you may heave laterally. Okay, I think this is worthy of adding to it. Now, he said heaving down the middle. We don't see this heaving here. We're at the middle. I'm going to back up just a couple of seconds. And I'm also going to talk about expansion again. This wanting to expand compared to this. And then you have this corner. This is where when a differential expansion may take place, why you may see that crack come off of there may. This is where he's done his repair. But look right, the information is right when he turns around.
Okay, there it is all
poured. Let him turn around a second.
Steve's going to start edging that.
There's those differential corners that you mentioned. All right, now he turns here. All right. So as we've observed this, remember he's dealing with the one section there and one there. This looks like, he's not repairing it. So this means it's a significant amount of area that's not behaving the way that the rest of it behave. This is why I would eliminate the slag as the issue, because then this should also be an issue, right? That's an issue. This should be an issue. It appears they've got a loading dock that they created, if you will, a loading dock they created at that one, at this, let's back up. Let them play now. And this down. So it appears they created by accident a loading dock. And if we look down this, the driveway down here, straight ahead in this video, straight ahead this way, there is a way to move around a bit around in here. Now let me turn this around. Oh, this is that lift. All right, right here. All right, so let's look at this as a loading dock area. All right, interesting. Maybe they move these for this time, but that stops there. So maybe the trucks come back, they stop, and this becomes a loading dock. And I don't mean a dock as in elevated loading dock. A loading dock where the tractor trailers come back. Multiple years, that's free, slamming on brakes at different locations, and you start fracturing this all to hell. Now, he would theorize that they wouldn't just offload back there, and then this is, you would unload here also. But these bins almost appear empty, like this is their staging for exiting, so lighter loading here. These bins don't, the way they're stacked, they're taller stacked, and so they appear like these are the empties, and these might be the fulls, two stacked twice, and then whatever this may be. And again, they isolated the pathways to them. Now this is not for free. You don't get to isolate all that loading over here and over here for free. This could be the depressions or creep over time, this side and this side, giving you also your tension in the middle. Isolate that damn thing.
It's getting pretty empty. I'm kind of thinking we don't have enough for this pad, but we'll go as far as we can.
Because you know, I like his work. I like his craftsmanship. Just giving him some professional advice here. All right, there's his rebar. Let's assume it's the same. It's tying into existing pad. To what end, can't really say. If you've got the pad, if you got that base locked in tight enough, jack tamp would be jumping jack would be awesome, would be better. All right, I see a crane in the background, so it appears to be a crane, that yellow crane, so that's some heavy lifting there. All right, so he's rolling in and out in his truck, and here we go. All right, so I have to state this then. He's putting in some cuts, right? And so these should have been around the entire perimeter. If you're thinking this way, you should have also put expansion around the entire perimeter.
We're going to go ahead and put our tool cuts in today. No saw cutting tomorrow. 1, 2, 3 cuts, and that's it.
So if you think you need those, then you should also put expansion around everywhere, in my opinion. Based on expansion, also the mix. I hope this is not air train internally. We got bleed water coming up. I don't like that metal trail, which is going to now feather it with
okay. This is all done. Jim, we got one little spot right up there.
Unless he's going to feather it with a broom, but pretty quick.
1, 2, 3 pads are done. Okay. Final pad, final truck. This.
Okay, so he's broken it up into pads. With that said, they should have been isolated with some expansion. Now, can he still get away with saw cuts? Yes, these are still salvageable by saw cutting. Saw cutting right around the edges. It'll have it'll still work. And then fill it, but because these are not, these got steel across here. Can't get my pen to work. Sorry, guys. I'm going to do a separate video on this one day, but I want to talk about the defect that is created by a trowel joint right here. I think I might give you a peek of it. Or rather, I want you to try to tell me, how can that be a defect? How can that be a defect? All right, be careful. I do Colombo communication. How can it be a defect? Meaning a defect would be something you didn't intend it to do. It wasn't your intent, but it's a result of. So the intent of the there's to be a control joint, right? All right, tell me why. Tell me why that's a defect as it stands. If any way to the end of his video, he talked about expandable soils. He stated Colorado Springs. All right, expandable soils. Hoss is a very if it's not expanding, it's very stable. It's very nice. You need moisture to have it expand. So consider where your moisture is that will cause the issue. Otherwise, clays are some dense, very dense products, and that's your expandable soils. But if you can keep them from moisture content, you have a brick. Oh, wait a minute. They make brick out of clay. Huh. End of video. Take care. Again, this is not an attack video. This is just hopefully constructive criticism.